algebraically. Okay. So this is where you guys might remember back from Algebra 1, we had graphing was one of our methods of solving a system, and then we had two others, substitution and elimination. So I'm going to show you guys, well, actually, I'm going to write out some steps here. So I'm going to do that just up top here. So substitution, what's important is we want to isolate one variable and then substitute the equivalent expression into the other equation and solve. Okay, so before I give the elimination one, I'm going to just walk through what that means. So substitution, we are going to isolate one of the variables. So if one of your variables is already isolated, this is the easiest method. Or if one of your variables is really easy to isolate, it's a really good method too. So right here, this y is going to be pretty easy to get by itself because it's just one step. I just have to subtract the 2x to the other side. So I'm going to go ahead and do that. So I'm going to rewrite it as y equals negative 2x plus 3. Okay, and then I'm just going to rewrite the bottom equation here. So I've isolated one of the variables. In this case, I isolated y. It does not have to be y. It can be the x, so whatever's easiest. Okay, so this expression that's equal to y, I can plug in for y in the other equation. Okay, so we're allowed to substitute things that are equal. And right now I've established this is equal to y. So I can substitute it into the other equation. So I'm going to rewrite the other equation exactly the same way, but instead of y, I'm substituting in negative 2x plus 3. And now I can solve this because it only has one variable. So I'm going to go ahead and solve just like I normally would, simplify, and then get x by itself. So I'm going to distribute here. So I have 3x plus 4x, negative times negative, and then minus 6 equals 8. I get 7x equals, if I add the 6, I get 14. So divide by 7, and I would get x is equal to 2. So remember, a solution to a system, I need an ordered pair, which involves an x coordinate and a y coordinate. So far I have the x. Now to get the y, all I have to do is take my solution for x, and I need to plug it back into one of the original equations. It does not matter which. So I'm going to take it, and I'm going to plug 2 back in for x, and I'm actually going to use, this equation, which works as well. Yeah, that's fine. You can do this one that you've rearranged or one of the originals. It really doesn't matter. Okay, so I'm going to plug back in. It just has to be one that involves y because I'm looking for y. So I'm plugging it back in for x. So now I have y equals negative 2x we now know is 2 plus 3. Simplify, y equals negative 4 plus 3, which is negative 1. So my solution is 2 comma negative 1. Okay, elimination. Okay, and I'm going to write my directions here. So elimination is we need to multiply one or both of the equations to get the same leading coefficients with opposite sign on either x or y. Add the equations, then solve. Okay, so this one is probably my favorite one, actually, you guys. It tends to be the quickest. If I want to solve, I'm going to actually do the same exact equation just to demonstrate that we can solve a system using a variety of methods. So I want to look at my system here, and I want the same leading coefficient, but I want one positive and one negative. The reason I want that is because when I add the equations, I want to eliminate one of the variables. So I need them to be the same, but one positive, one negative. So I'm going to rewrite the system here. Okay, so here's my options. I can get my x's to cancel, so I need to think about things that 2 and 3 go into, so I can multiply them so that they're 6, one positive 6, one negative 6. Or the y's, right now I have a 1 and a negative 2. So here, if I multiply the top equation by 2, I would have positive 2y and negative 2y. So that's the easier one because I only have to multiply one equation instead of both. Both ways would work though. So I'm going to choose to multiply the top by 2. So notice I put the whole thing in parentheses because I also have to multiply this 3 by 2, every single thing. Okay, so I get 4x plus 2y equals 6. I didn't multiply the bottom equation, so I'm going to keep it exactly the same. And now I'm going to add. Okay, so this is the elimination part. So the whole purpose of multiplying by 2 is now we eliminate the y's when we add, and then I add like terms. 4x plus 3x is 7x. 6 plus 8 is 14. Divide by 7. So I get x equals 2. And again, I just need to take that 2 and plug it back in. I'm going to plug it back into this equation here. So I got my 2, and I'm going to substitute it in there. Oh, not for y. 4x. There we go. So I've got 2x, but we now know x is 2, plus y equals 3. So 4 plus y equals 3. Subtract 4, and we get y is negative 1. So then again, we can see my solution is 2, negative 1. And we should get the same thing. It shouldn't matter which method we chose. The solution is the same. Okay, so now we can choose whatever method we want. What's really important for any of these methods, substitution or elimination, if we're going to use elimination, then I do want the x's lined up, the y's lined up, and the constants lined up on the other side. So it just kind of depends on what we want to do. So I'm going to go ahead and use elimination because all the variables have coefficients, so they're going to be a little harder to isolate. And I just like elimination the best. So I'm going to go ahead and add the 8 over here and subtract the 3y over here so that it's lined up x's, then y's, then constants. Okay, so I'm going to leave the bottom equation the same, and I'm just going to rewrite this one here. Okay, so we've got adding 8, subtracting 3y. Okay, so here's now my new system. So I'm kind of ignoring the top here. So now I need a to eliminate one of the variables. So I could either multiply the bottom one by negative 2 to get 10 and negative 10, or I could try and eliminate the y's, which interestingly enough, I would also need to multiply by negative 2. So let's see what happens here. So I'm going to multiply the whole bottom one by negative 2. Okay, so I'm going to rewrite the top equation. It's going to stay the same. Okay, so multiply the whole bottom one, we get negative 10x plus 6y equals negative 16. Okay, well, look what happens here. When I go to eliminate, my intention was originally to eliminate the x's, but look, the y's also are eliminated. So I have nothing left over here, meaning 0 is really what's on that left side now. And then 18 minus 16 is 2. Well, we've seen this before back in Mod 2, and we get something that's untrue like this. We say that this is a contradiction and there is no solution. Okay, so we can use this symbol, which means the empty set, or we can actually write out the words no solutions. Okay. All right. If we were to get something that is true, we've talked about that before too, it's an identity. So if I got something like 0 equals 0 or 2 equals 2, then we have infinitely many solutions. Okay, and I believe you guys, that is our last example for this